The third specimen is cast acrylic, huh? And Professor Dressler has already set that up.
We've already fixed the upper and the lower jaw, keeping in mind the separation between the specimen heads and the jaws. And we've taken care of all the other things. We've entered the values of the diameter and the gauge length. The test has begun, just like others, and you can see the cross head increasing along with increasing load.
So, since this sample is acrylic or plastic instead of a metal, we should expect a drastic difference between the first two samples and the third one. So, hopefully, this experiment would reflect that.
Also notice how the acrylic changes its color from being clear to something like being whitish in color, so it's not that transparent as it was initially.
Yeah, translucent mode kicks in.
And also notice at 0.13 something inches of displacement, crosshead displacement, the load value is only 800 or 900 pounds.
Which is pretty unusual compared to the previous samples.
Mm-hmm. So this has much lesser stiffness as compared to steel or aluminum specimens. 1,000 pounds.
Well, that's a lot.
Yes.
But not as much as that of the previous ones, right? We've
Yes.
seen something like 7,000.
Yes. 10 of me can hang on an acrylic specimen and it won't even fail, right?
It won't even fail. And speaking of failure, we can already see a detour and it has failed.
So this was very quick, and as you can see, the sample had a very clean breakage at 90 degrees or perpendicular to the
Axis?
the axis, correct?
No, so this is a brittle type of failure, huh?
Yes. As you can see, the sample basically was cleaved into two pieces cleanly.
As if it was cut by a saw.
Oh, yes.
That's the property of this kind of materials. So now we measure the differences in the gauge length, and then that will be useful for us when we are calculating the strains.
I feel that there would not be much difference, like it would be almost the same, the diameter and the final length would be the same as the initial ones.
Final values are being coded, and then they are being entered so that now you can see the stress strain plot.
And there's not much plastic region, so this is brittle, huh?
Yeah. So most important thing that we just did is entering the datas and getting hold of the final values so that we can have it. Here you go, here are the final values. This is the file that we need to work on for this sample, and we're going to save it as a text file using a convenient name so that it is okay for everyone.
And the file should be intelligently named.
That's correct, as we've already stated previously. So the file is now saved, and this is the little experiment